Hello geometry students, here's your lesson for section 4 for congruent triangles. Missy McCarthy, Okemos High School math instructor. In this lesson, we're going to learn how to use properties of congruent figures, and we're also going to learn how to prove that triangles are congruent using the definition of triangle congruence. So in this particular slide, all I wanted to iterate is what the meaning of congruent figures is. So congruence simply means that the figures have the same size and the same shape. When they have the same size and the same shape, that means that they have the same number of angles, and therefore those figures have angles that correspond with one another. So corresponding angles and also corresponding sides are the sides and angles that are in the same position in the polygons. Two polygons are said to be congruent if and only if all of their corresponding angles are congruent and all of their corresponding sides are congruent. So you can see here for the properties of congruence that we have two different figures. So this applies to all polygons. If you have two triangles that are congruent, that means every single angle has a corresponding angle that is also the same size as it. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Also, if you look at the side lengths, AB matches up with DE, and so on and so forth. Again, this applies not only to triangles, but to any polygon, so you can see whether or not this rectangle is oriented vertically or oriented horizontally. The corresponding angles are still all congruent, and the corresponding sides are still all congruent. So in this particular problem, we are being commissioned to identify what the corresponding sides and angles would be. It says corresponding parts, but that means sides and angles. So the corresponding angles, we would say that angle P would be congruent to angle S. We would say that angle Q is congruent to angle T, and angle R is congruent to angle W. Now for the sides, we're going to say that side PQ, the first two letters of the first one, is congruent to side or segment ST. Segment QR is going to be congruent to segment TW, and segment PR is going to be congruent to segment SW. So they're all of the congruent sides and congruent angles. Now for this particular problem, we're being told that triangle ABC is congruent to triangle DBC. So I'm going to trace triangle ABC in red. Triangle ABC is this guy here. And then the other triangle that we're looking at, it's important to know which triangles we're looking at, are DBC. And we know that angle DCB is a right angle. It's marked right there. So what are the corresponding angles? Well, A corresponds to D, ABC corresponds to DBC, and ACB corresponds to DCB. So therefore, we can say, to find the value of x, we can say that 2x minus 16 has to be equal to 90 because these two angles correspond to one another. So we would add 16 to both sides, and we get 2x equals 106, and divide both sides by 2, and the value of x is 53. Now it says find the measure of angle DBC. So DBC, that would be this angle right here. We've got to find the value of that. Well, if we know this is 90, and we know that this is 49.3, then all we have to do is subtract this from 90, because in a right triangle, these two angles are complementary. So the measure of angle DBC would end up being 90 minus 49.3, which would be, I believe, 30. or 41.7, or 40.7, my bad, 40.7. When we're proving triangles are congruent, it's important to keep in mind that we would need to show that all corresponding angles are congruent and all corresponding sides are congruent. That is the definition of congruent polygons, or the definition of congruent figures. So in our next problem, we're going to do a proof, and we'll have to make sure that we show that that's the case for every corresponding angle and every corresponding side in order to draw the conclusion that the triangles or the figures are indeed congruent. So here we're given quite a bit of information, and that's good. That means we are only left to prove a certain amount of information. But here we can see that the first thing we're given is, let's see, statements and reasons. The first thing that we're given is that YWX, and YWZ are right angles. That's lovely, because by the right angle congruence theorem, we know that right angles are congruent. So I'm going to write what I'm given. YWX and angle YWZ are right angles. One given. So again, since our challenge, because we're trying to prove that these triangles are congruent, our challenge is to prove every pair of angles congruent and every pair of sides congruent. We can say that these are congruent by the right angle congruence theorem. So we've got one pair of angles down. That means that angle WYX is congruent to YWX is congruent to YWZ by the right angle congruence theorem. All right, now the next thing we're given is that segment YW bisects XYZ. So segment YW bisects angle XYZ. That's given. So as a result of this being the bisector, we can say that XYW is congruent to ZYW. These two are also congruent. So angle XYW is congruent to angle ZYW. And that is by what? Definition of a bisector. All right. Now we got one more set of angles to prove they are congruent, and that's this guy here, angle X and angle Z. And because two angles in these triangles are already congruent, that means the third angles are congruent by the third angles theorem. So angle X is congruent to angle Z by the third angles theorem. All right, so now our charge is to prove that all three sides are congruent. So step 6, I'm going to come up here and draw the rest of these steps. Step 6, we know that W is the midpoint. That's wonderful. W is the midpoint of segment XZ. That is given. So if this guy's the midpoint, that's congruent to that. So 7, that means that XW is congruent to WZ. We got one pair of congruent sides. That's definition of midpoint. Okay, then they tell us that XY is congruent to YZ, another given. I love it when there's lots of givens. So we know that this is congruent to this. So we need one more pair of congruent sides, and that would be these congruent sides right here. We can say that YW is congruent to itself. And that would be by the reflexive property. So now we've proven that all the angles are congruent and all the corresponding sides are congruent. So that means that finally the triangles are congruent. XYW is congruent to triangle ZYW. And that is by the definition of congruent figures or polygons or triangles. Either one of those would work. All right, there's one more proof on this page. I want you guys to take a look at this one. See if you can figure it out, and we'll do it in class tomorrow. Okay, see you then. Bye.